So here's a picture took in Ho Chi Minh City in 2018. A natural event is happening and we all know that it is lightning. And since the tall buildings like the landmark 81 here is designed to withstand the lightning strikes many times, but we should always try to understand the phenomena and be aware of its potential risks. So today in this video, I will talk about lightning and I will explain it using Coulomb's law and I will do it in a very general perspective. So lightning is a result of static electricity and static electrical charge built up when two objects rub together as we know. And in the case of lightning, the objects are the moisture molecules and the ice crystals and also the dust in the clouds. So let's talk about the clouds. In the process of water cycle, moisture accumulates in the atmospheres to form clouds, and clouds are made up of billions of dust-borne water molecules and like ice crystals, and they begin to move faster and faster when they rub together. Then the electron will be knocked off, and it will create a charge separation. So according to Coulomb's law, opposite charges attract each other while the like charge repel each other. So as we can see here, different interaction between clouds, air, and the ground can happen. And whenever there is imbalance between electric charge, which can be explained using Coulomb's law. So lightning can occur within the clouds, between the clouds, or between the clouds and the air, or between the cloud and the ground. So actually the most common type of lightning is called the intra-cloud lightning, which is the lightning between clouds alone. So the other type that we care most about are lightnings between the ground and the cloud. So either from the ground to the cloud or from the cloud down to the ground. And this is can happen when there is a conductive path. So the existence of this conductive path can be explained using the electric field, which is exactly the Coulomb's law in a larger scale. So the electric field will exert force on the positive ions and the negative ions, and this force is of course according to the Coulomb's law, and that is why the air is ionized. So the ionized air, or also known as the plasma form of the air, is much more conductive than the previous non-ionized air. Those conductive paths are like typically referred to as the stepped leaders. And these leaders will form different branches because the air may not ionize equally in all directions because of the wind, of the dust, of the weather conditions. So when a step leader descends from a thunderstorm cloud toward the Earth's surface, then it will create a conductive path that made up of ionized molecules in the surrounding air. The step leaders are mostly invisible, except to like very high quality, very high frame cameras, like we can see here. The objects on the ground reach out to the cloud like by a phenomenon called the growing of positive streamers. It's just like the interaction between opposite electric charges from the cloud and the ground. As you can see, since the step leaders can form differently in the air, which makes the lightning can be very unpredictable and in some cases very dangerous. And we have seen many cases when lightning could strike on the beaches and hurt people. So the positive streamers, as I mentioned, is like a connecting point of object on the ground to the touch clouds above. So after the step leader and the streamer meet, like the ionized air has complete its path to the earth, and it will leaving a conductive path from the cloud to the ground. And of course, the result is a flash, like bright and very hot, from the cloud to between the cloud and the ground, and that is lightning.